So we're going to talk about application security today. I'll be straight with you. This talk's 10 years old. I had to revisit it, I felt, because there's a lot of stuff going on in the world that impacts application security departments. And I got 10 years of experience building them. That at the time I wrote the talk, I only had like 5 years of experience building them. Now I have 15 in total. And that's really making the picture get kind of solid in my head. So I thought this is a good time to share it. However, this talk was designed for security people, not for developer audiences. That's one of the changes. When I started in application security, there weren't very many developers who gave a crap about security. I was one of very few. This was 20 years ago. Okay, but today, I would wager that most of you probably at least have a quarter of your vision on security these days. That was not true when I started, but we'll get into that a little bit. Gene Spafford, the curmudgeon of Purdue, he is the chair of the computer science or computer security. I don't remember, but he's way up there. So he tells us in no uncertain terms what he feels like security appears to developers especially, and to him particularly. For those who might not be able to, I heard it's a little fuzzy. It doesn't seem too bad to me, but it says, the only truly secure system is one that is powered off, cast in a block of concrete, and sealed in a lead-lined room with armed guards. And even then, I have my doubts. I can't say off the top of my head that I disagree with him. So you're probably wondering who the hell I am. My name is Bill Sempf. I have been in this community for an extremely long time. I spoke to the Corel users group in 96. So that gives you an idea how long I've been doing this kind of stuff. For the first half of my career, I was enterprise dev. I worked on a large number of projects. I was on the Travelport project that ICC did back in the day that was a big set of services that kind of revitalized the way airlines communicated with the web. That was really a neat project. I did a ton of stuff for the state of Ohio, including I was on the project that ended up with OHID that gives the universal single sign-on for state websites and applications and whatnot. So I've been around for quite a while, but after a while, if you're one of those software engineers that just keeps your hands in the code until you start to get gray hair, you got one of three choices. You can go into marketing or sales, right? You can go into management, take the executive path, or you can take on all the hard problems. And that's what I ended up doing. I don't know why. Somebody shoot me. No, not really. It has its ups and downs, that's for certain. As it turns out, at the time especially, and maybe now more than ever, security was a hard problem in application development. So I would go on projects and consistently get the encryption, the encoding, input validation features, authentication, authorization, session management, all the access control bits. And I started to learn the security stuff by accident. And then eventually I realized, I might as well just call myself a security guy because that's what I am. So that's where I ended up. It has been an interesting ride, that's for certain. So here's what we're going to talk about. First, we're going to try to lay out what the problems actually are and what the solutions might be, just to give us a spec up front. Obviously, the whole talk is about problems and solutions, right? But we're going to be specific there. We're going to find out that the problem is that we need more application security people, and that the solution is we need to make them. And that's makes for some interesting conversation as we get on. We need to ask ourselves what those people need to know and then how we teach them. Once again, problem solution, right? And then we're going to do as we always do. We'll finish by getting started. As they taught me, you tell them what you're going to tell them, you tell them, then you tell them what you told them, right? Am I right? I'm right. All right, let's talk about problems and solutions. I don't think anybody has any question about whether or not we have problems with application security. I mean, you almost cannot pick up a newspaper. I almost said pick up a newspaper. When's the last time somebody picked up a newspaper? There are probably people in here that have never picked up a newspaper. If you've never picked up a newspaper, oh my gosh, there's a couple people out there that I can barely see. Oh wow, there are people out there. Hi, people. Anyway, we have an issue that the largest companies on the planet are repeatedly proving that they can't take care of their stuff. Unfortunately, their stuff is our stuff, and that's becoming a bit of a problem. And yeah, I mean, it just keeps going and going. So I don't think anyone has any questions about whether or not there is a problem with application security these days. We're in a not so great spot. And we've been working diligently to solve it. It's just big. It's big for a really good reason. You see, we have an interesting space here where we've been writing software now for 30, 40, 50 years. I mean, if you go back to mainframe stuff. And, well, 50, hell, that's right. Geez, I've got to adjust my time frames, don't I? 50 years ago wasn't mainframe stuff. I was writing software 50 years ago. No, I wasn't. No, 40 years ago. Okay, you get the idea, though. We have a huge backlog of flaws that we don't even know about. And so, to find them, we hire people like me to go and test the application for 2 weeks and write down everything that's wrong with it after there's been 10 years of development on the application. I have an application right now I'm working with software architects on that is 15 years old, and it's vulnerable to SQL injection. And so the CIO says, so we need to edit some code. And I said, yeah, but the problem is the architecture of the application is such that everything is injectable. Because the decision was made when the application was started to build your data layer this way, and now it's all vulnerable. So it all needs to be ripped out and replaced. That's the kind of weight we're dealing with here, with this iceberg we're faced with. So why do we talk about application security at all, right? Because there are, for whatever reason, folks out there that have decided that stealing our information and using it against us is a profitable enterprise. Whether or not that's always true is arguable, in my opinion. I mean, I've had some pretty involved interactions with the criminal element, and I'm not always entirely certain why they break into wherever FedEx and steal 1 billion records or something. It's like, I mean, are you just trying to shame the company? I don't completely get the perspective. The problem that we're faced with is that those attackers, for whatever their reasons, can work 24 hours a day, 7 days a week, 52 weeks a year, to break into an application if they sufficiently want to. I get 2 weeks to find all the things that'll stop them. That is non-trivial. So we stand here at the corner of the problem and the solution, right? We know we have a problem. We don't entirely know why. I mean, obviously there's some things that would be beneficial for being stolen electronically, but I mean, baggage claim records, it's like, what? But anyway, The solution, as it turns out, is not just that 2 weeks of testing. And if you talk to the regular InfoSec folks, hardening the boundary of your organization. That's a whole nother talk. Those aren't the standalone solutions here. The fact is that we simply need more people who understand security and applications. And that's exactly what I set off to make 15 years ago when I kind of hung out the shingle saying, okay, I'm an application security architect. Now, my title, at least as far as the state was concerned on my last project with the state, was Senior Application Architect, which I always thought was kind of an interesting term. But when you're doing application security, it is in a lot of ways architecture. You are building scaffolding for developers to work on and within that provides more secure code by default. So application security architect sounded good to me. I don't know whether it was me or several of us had the idea at once, but for some reason it really caught on. And 4 or 5 years later, everyone was hiring for an application security architect. And there's a reason for that. I mean, in the normal IT realm, security knowledge is extremely worthwhile to have in the industry. I mean, it can get you your next job if you can talk about security and talk about how you've implemented it and worked within the security team's messaging and whatnot to build the applications you build. People who hire you want that information. And that's not just hiring for application security people. I'm talking about for all developers. If you're able to talk about how you secure your code, it makes you more valuable to the hiring manager. But that's not even what we're here talking about. We're here talking about building people that are specifically designed to work on the security of a given suite of applications. Or, even better, like I said before, build an environment where the developers are writing secure code by default. So a friend of mine, Aaron Reinhardt, who is the security architect for United Health, says, hey, we keep trying to yell at our developers about security. Why don't we take our, security people and teach them software engineering so they know what's going on with that? That has promise. Right here in town, as somebody who's very well known in the security industry, Brian King, 100% goes by BB King online if you run into him. He works for Black Hills. He started out as a network guy. And he learned application security with me on his team, helping, in enough years that now that's mostly what he does, is application security, with no background at all in software development. But the fact is, it's really, really hard to build tools for developers to build more secure applications if you aren't a developer. It's hard. And it's hard to implement the ones that other people have built. Because unless you've done the process, it tends to make people think they need to change the process, that we're all using the right software and not, oops, did I go back forward? No, I didn't. See, I sit and play with this in my hand, and my old clicker had a button that would turn all the screens off. So I'd be talking and talking and talking, and I bump the button and the whole place would go dark because the screen would go dark. That's a lot of fun. Anyway, where was I? So I'm not entirely sure that I agree with Aaron. I think we've been bringing security to the developers the wrong way for a long time. So let's talk a little bit about how to make new application security people, right? So people come to me all the time and ask, hey, how did you get in application security? I want to do this stuff. How did you, and this is like college kids, people looking for their first step in. And I don't say it anymore because it really feels like gatekeeping to me, and that doesn't ride well with me. But in my head, the answer is, well, first spend 15 years writing enterprise software. And then, because you have to be able to walk in with an understanding of how software is built in order to understand where the security tends to fall on its face. But there is no process, right? There is no process for building these people that is anything even vaguely resembling any kind of quality. So we're going to try to put that together here today as best we can. Sound like a plan? So the largest issue that I've run into with Aaron's idea of teaching security people application development is the amount of things they need to know in addition to the security stuff they already know significantly outweighs the stuff that you need to learn on the security side to make yourself balanced. Obviously, you have to understand how software is built. You know, what the use of OAuth, for instance, and JOT-based token-driven authentication authorization is really hard to get a grip on if you don't understand how the application is maintaining state and how it's running. Trust me, it's an argument I get. Oops, I did it again. Trust me, it's an argument I get into with InfoSec departments all the time. It's not. We all know how demanding software architecture can be. Figuring out the best way to solve a problem, figuring out the best, most secure way to solve a problem adds a difficulty level of magnitude higher, right? You also need to understand web frameworks. In this crowd, that's probably where we have the most of here, but it's surprising how people in the security industry view, there's that front end code, and it's ta-da. And don't worry about that, because I'm worried about the servers, our cloud instances that are there that can get directly, I'm not too worried about the web framework that people are using on top of that. I'm worried about the operating system and the core stuff. But see, if you're trying to prevent people from getting to the operating system and the core stuff, you have to understand how the web frameworks are mapping the information that are coming in from the user and going out. That's difficult to explain to a non-software developer. Whereas for all you folks, you probably could teach me. All right? I keep bringing up examples of data that's stolen and how I never really figured out why some of it's stolen, but whatever. Databases in all their forms is something else that an application security specialist needs to understand, because that's the crown jewels, well, most of the time. That's where the information is kept that we don't want to distribute out to the public. We want to maintain control over it of some level. Some things are obviously significantly more important than others, but understanding those levels of data is easy. GRC people do it, green, yellow, red data, no problem at all. Understanding what you have to do within the database to make sure that only certain people can see these 4 columns, and understand that that's even possible, that's a software developer's job. But you have to bring the security in with it, and that's demanding when it comes to databases. You're probably going to have to know something. We're talking about application security people, right? They're probably going to have to know something about mainframes. There's still something like 65% of the world's economy is walking through COBOL code that was written in the 70s. you guys got to understand. Application security people have to understand what that means. A DB2 instance is not just some other database on your system like a Redis database or a SQL Server or Oracle sitting someplace. It's a whole beast unto itself. And knowing that and understanding the intricacies from a developer's perspective bring all software developers so much closer to the truth as far as securing the information that's on that mainframe. Now, actually building secure mainframe systems, that requires a team of people. Because talk about the what do you need to know section for that, it's incredibly broad and very detailed. But conceptually knowing the difference between the way computing was done in the 70s and 80s and the way it's done today, and how those security needs differ, especially with the bridge between them that we're all building most of the time. Not most of the time, but you know what I mean. That is key to all of this. So, ZOS rules, by the way, big fan. Wait a minute, I pushed the wrong button. Okay. So, application security people, and this is where the developer crowd suddenly starts to get a little weaker, probably. An application security person needs to understand what the bad guys do. For instance, my example earlier of, why are they bothering to break into the tennis club and steal their member list? Yeah, okay, those emails are good for phishing maybe, but aside from that, what? Who cares? But the fact is they are. And you, aspiring application security people, and your teams, application security teams that are aspiring to new heights, need to be able to integrate that into all this space. I'm not suggesting that everyone in the application security department needs to be a threat intelligence specialist, which is funny because I'm kind of getting sucked into that world right now, and it's a weird world. So threat intelligence is exactly what it sounds like. It's keeping track of vulnerabilities and how much of a threat they actually are to applications and the systems that run those applications. Yesterday, for instance, and part of the reason why my brain is a little befuddled today, actually 2 nights ago, late at night, but effectively yesterday, a new vulnerability in Linux was discovered by something we're going to talk about in a few slides. It's called copy fail. You'll probably hear about it because it's probably going to be ugly. An AI security company ran the Linux kernel code through its model and came up with this vulnerability, asked it to write an exploit for it, and it did. And it works. So no matter what side of the AI argument you were on, whether it's all trash and it's just putting gunk into our system, or it's the greatest thing since sliced bread, or you're somewhere in the middle, those couple of facts are facts. I mean, this code's been in place since 2017. It's been reviewed countless times. Nobody found the flaw. Yay, open source. This thing it is legitimately a flaw. They have legitimately patched it, or they're working on it anyway. The exploit that it wrote for it does work, and you can, if your Linux system, and I mean, I'm not talking like the Ubuntu laptop you have on your desk, I'm talking the camera in here that they were playing with the IP number for earlier, right? If it's got anything even vaguely resembling a shell on it, you can own it. It's ugly. And I spent all day yesterday helping people test various and sundry things for that, point of sale systems and stuff like that. So knowing what the bad guys do is a key part of all of this, just so you know what you're fighting or defending against. Then you need to know how to use your tools. Talk about a whole nother talk, right? I mean, this is literally a whole nother talk. The tools that are used by application security folks are in many ways dramatically different from anything you're used to working with. And historically, though I haven't been in front of enough developer groups recently to verify this again, not really since lockdown. I need to get around devs more a little bit, because I don't know if this is still true, but historically when I've taught developers application security, it was a shock to discover that the attacker does not care at all about their web coding. The HTML, CSS, JavaScript, even your fancy JavaScript that like checks to make sure you're putting the right stuff in the right place and all that other BS that does in the UI, the attacker isn't attacking any of that. They're calling whatever the JavaScript's calling under the covers, right? We're directly attacking the server via HTTP. Request to response pairs, gets, posts, like that. That comes as a hell of a shock to most people in the programming world, and honestly, most people in the security world too. So this is key thing. What's on the screen here, probably very fuzzy. It doesn't matter what's on it, fortunately. So, yes, it does matter because I want to make sure I name it right. Okay, this is Zap. So that is an old picture of Zap. Zap is an attack proxy. It literally stands for Z attack proxy. And it is designed to sit between the browser and the server and muck around with all the requests and responses that are going back and forth. I gotta stop playing with this thing. That's where all the magic happens. And tools like Zap help us to do it. But you think your IDE is complicated? These things are unbelievably complex, and you need to spend an incredible amount of time working with them to get good with just the tools, not to mention all the things you need to work on to make the tools happen. So this is something else an application security person needs to know. But see, I've been forced to add stuff to this talk, and there's been other things throughout, but that's okay. This is kind of the main thing I wanted to go in there, is the elephant in the room. Because as it turns out, just in the last 6 months, maybe even 6 weeks, AI has changed probably 80% of application security. And that is not an exaggeration, and I'm not saying that for any other reason. Trust me, there is no one here who wants to talk about AI less than me. I'm not particularly good with using that tool yet. I'm still working on it. It's moving way too fast and blah. So but we will get to it. But anyway, you look back, all the developer stuff we need to learn, all the bad guy stuff we need to learn, the tool stuff we need to learn so that we can sit between the applications and the bad guys. What are you looking for? You're looking for unicorns to build an application security department. There are not very many people who can do that. There are not. I fell into it by accident, and that's now my answer. When people say, how did you get into this? I say, I tripped and fell face first into it. I did not mean to become an application security person. It just happened because I guess I'm kind of good at it, and I just happened to have the right things in front of me to have the skills already there that were needed. I just needed to have that one little piece on top to get there. And that's, I think, you'll find a lot more people like that in your organization than you believe. But we'll get there when we talk about, oh no, that's right, first we have to do this. See, this is the new section. But first we're going to talk about what the hell we're going to do about artificial intelligence, right? The fact is, I'm going to talk purely as an application security person. Okay, this is not a moral or technical review of AI at all. But business use of artificial intelligence is very risky from the pure risk perspective. largely because we're defending something that no one, including the people who wrote it, actually understands how or why it works. How do you protect something like that? It's a little bit more involved than you would think. So at the end result, what we as application security people are trying to defray a little bit is risk, right? We want to tell our boss, company, client, organization, whatever, how risky it is to not fix that flaw. I mean, is someone going to break in? Copy fail? Yeah, probably now. The next 3 or 4 days might be super ugly. Keep your eye on the news. Might not be. We might get fixes out in time. CERN came out with a patch last night at around, 1 a.m. Not a patch, but a service you could turn off on a Linux box. So maybe not the big deal. The fact is that no matter how you slice it, using AI as part of your business story has a ton of inherent risk baked into it. And then any application security pieces, the code security things on top of it, we have to be responsible for without really understanding what the model's doing under the covers. Because honestly, nobody really understands exactly what the model's doing under the covers. I mean, you can kind of watch, but not really. So, yay, it's magic. AI in software development is risky. It probably might not be a super happy topic for this group, but the fact is that I have worked with way many more people that have written an entire application using AI, got it up working, all the features work, everybody loves it, it's fantastic. Took me 45 seconds to completely take it down and own all of its data. But I told it to secure the code. See, look, right here in my context file. Yeah. It's risky. And you think it's risky at that stage. What about when you get the ticket to go fix it? Are you going to go back to your dev console 3 months later and say, hey, we need to fix the SQL injection problem and have it rewrite your entire code base for you? Because that's what happens. So there are risks involved there as well. And more than anything else, right now, AI in the hands of criminals is risky. And that is not a risk we can actually push ourselves away from at all because it's in the bad guy's hands, not ours. So we can say, hey, having the chatbot maybe have access to our entire underlying database, that might be a little too risky. Great, control. I like controls in place. That's good. Developer side, okay, maybe we'll use AI for certain parts of this, but we need to make sure we maintain our hands in the code base all the time for this reason, that reason, and the other reason. Okay, good, controls. I like controls. We have no control over the criminal element. They don't care if they're using the models to do bad things. They want to do bad things so that they can steal our tennis checkout records or whatever people are getting these days. I just don't understand the data theft thing, but they are using AI to find the vulnerabilities in the neatest of ways. So, how many people here, your organization's on a bug bounty program? Oh, really? Nope, just a couple. Wow, okay, that's kind of scary. Okay, well, bug bounties, pen testing, whatever. I have a customer who's under a bug bounty program, and this mind-blowingly elegant vulnerability came in. It was a remote code execution that looked like it led nowhere, but where it actually led was to a known flaw in struts that would give you complete root access to the underlying server. Like I could run a post command, and it would return back to me the directory listing of the root of the server. I could go, code together a thing, add myself as a user to that server, go log into that server. Yeah. We thought, wow, This is a really good find. How did he do that? He used AI. 2 agents, one looking for flaws in the application, one looking for what it learned from the error messages, taking the error messages from agent 1, and looking at the source code of the tools that they were using that were returning the error messages, in this case specifically struts, to find vulnerabilities that they might be able to use there. Matched them up, wrote the vuln for him. I am not kidding. Now we got that, fortunately he told us and not, some criminal organization. I gotta wonder how many more vulns are out there for this one customer that we do not know about, because the person who found them using an AI wasn't working for HackerOne. They were working for an APT group. So all of this, all of these things that attackers do, write phishing emails, right? Data poisoning, just hacking in general gets assisted. Building adversarial networks, even something really simple like password spraying, all is better when run through a large language model. Even I wrote a little app in Rust. I mean, this is all, and I'll talk about this in a second, kind of. An app in Rust using a developer console, an AI developer console, that fuzzes the application until it finds an error, where it comes back and says, hey, large language model, I'm getting this error. What kinds of vulnerabilities, what kind of fuzzing might I try to find a vulnerability in this piece of code? And it recommends stuff back to my running fuzzer. It took me an evening to build that. You think the bad guys aren't working harder than that? They are. Okay. So like I said earlier, this is not an AI talk. But I got no choice. I got to cover some of it. Security starts in the design process. If you stick with that perspective, it's going to take you a really long way. AI doesn't change this. We still have a software development lifecycle, and the rules we have in place for that lifecycle should still be enforced. In fact, oops. Okay, yeah, I forgot about that. I should have swapped those two. So, yes, should be enforced with that. So how are we going to enforce it? Well, you all, if you're not doing it already, which probably most of you are, need to put your hands on some AI coding to find out what the bad guys can do with it. You need to ask a model, hey, go look at my code and find all the flaws in it, vulnerabilities in it. Let me know how they be exploited, what it looks like. I don't recommend using it as the be-all and end-all of your understanding of security for your application. In fact, I specifically don't recommend that. But I recommend you doing it because the bad guys are. So go get a developer console, right? And go in and play with it. Ask it to look at things. Then take a look at your software development lifecycle. Hopefully, you have an SDLC document that includes security features. Those security features can be rolled into a common rule set that the AI will occasionally, when it's in the mood, follow, called an enterprise context. Different tools do it different ways. There's enterprise settings in Claude, Mistral, which is what I use. That's what's back here. Hey, I use the backup button for a real reason. That's Mistral. Highly recommended. European code. They have to follow the European privacy laws. It's nice. Anyway, build that enterprise context based on your secure SDLC. And it'll take, remember I was talking about the risks from AI in development? It'll lessen that significantly because you apply that all the way back at the design phase. And yes, okay, you still have to review it to make sure the AI is making the right decisions, but it's one step closer. Okay, Enough AI stuff. Well, maybe not all of it, but you get the idea. So we've got a lot. How am I doing for time? Oh, I'm great. We've got a lot. We've got a lot going on here, okay? We all know as application developers, we have the web framework piece, the architecture piece, the database piece, maybe even the mainframe piece. We've got that all codified in our head already. Anybody with even a few user experience have had to have their fingers in all of those things for at least a few minutes. Now, we need to go and learn what the bad guys do. And I strongly recommend that you do exactly that. And we'll talk about a process. I said there's no process, but there's a process for that. The common response to training is macaroni and fuck it. Finally, I got a response. I had to cuss to get a response out of this crowd. It's ridiculous. I'll tell my daughter that. She'll be very pleased. Seriously, how many of you have taken the required 8 hours of PCI online security training that is like useless? I mean, there's 2 or 3 of them that are okay, but oh my God, are most of them. The funny thing is, I have to take them because I consult to companies that are PCI. And so even though I've literally taught those classes, I still have to take the electronic ones just to get the certificate so that the people that are in charge of GRC don't yell at me. So I feel your pain, I really do. Hi. Is that good or bad? I've got 4 minutes. Oh no, I thought I had lots of time. All right, this is where we should be. We should be excited about applications here, about security training in general, right? So how are we gonna get there? This is how you're gonna get there. This is the most important thing. If I have to rush through the rest, that's okay. This is the most important thing, right? If you're gonna take this back to your organization and say, okay, we don't have any kind of application security, we need to get started. The first thing you wanna do is have someone do some training. I did not say electronic training. Have a human being come and work with your team to talk about application security. There's a gazillion of them. If you have lots of money, hire SANS. If you don't, hire anybody else because everybody else is cheaper. And do the training and find your security champions. Those are the people who stay after the training to say, you know, this is awesome, I want help with this, and look at this thing I did. Then, from those people, those security champions can do this 3-part thing underneath there. Build your secure coding standard, which should be derived from your SDLC that should already have security stuff in it, or I'm gonna go yell at your senior development staff. And then you put 4 types of scanning of your code in the middle of it. Now, extremely important with the AI world in place. We need to do the static analysis of the code using AI. But we also still need to do regular old-fashioned human being testing the application. We can do fuzzing dynamically using AI as well, and we should, because the bad guys are. And then the vulnerabilities that are discovered in these processes go into your JIRA or your equivalent to JIRA. They are flaws in your code like any other bug. This button should be blue, and you really need to output and code this because people are having cross-site scripting fun everywhere. Those are both bugs. They both go in JIRA. This process, best consumed with spicy food and expensive beer. Make it fun. Security is actually a lot of fun. We just make it horribly boring, and I don't know why, so I'd like to fix that. Take my last couple seconds to talk about OWASP, the Open Worldwide. Oh, my slide is old. Remember I told you this is a 10-year-old slide deck. I missed this slide. It is now the Open Worldwide Application Security Project because we don't just do web anymore. Let me tell you about OWASP. I'll tell you about OWASP. OWASP is a global organization that has that does 2 main things. Well, 3 main things. Well, two main things. One, it has meetings, global big conferences like this one, and then individual chapter meetings, which we do have here in Columbus, or we would if they would get our event system up. But as soon as we do, keep an eye out. I'll blast it via every channel. Follow me on LinkedIn, probably the easiest way at this point. And you'll see it. We'll go back to having chapter meetings again. Yay, once I can actually get the information out there. And then there are projects. There's meetings and there's projects. The projects, some are documents, some are code. Documents are basically best practices drawn from a global audience of basically everyone in the AppSec world. So it's literally very good stuff. Everything's in GitHub. You can see every change. You can see every author. You can go and ask the author a question. They'd probably love to hear from you. I always do when somebody asks me. The proactive controls have become my go-to favorite standard for teaching an AI what to look for in its own code generation. But it's also real good for you guys, for us, for all of us. These are the 10 things, seriously, do not have to take a picture of that. Go download the document from OAuth. I saw a flash of somebody's phone lit off the glass. Go to oauth.org and get it, because the paper, which is only like 50 pages long, maybe not even that long, 24 pages long, is excellent. Way better than this list. But this will give you a good idea what's going on there. But most importantly, and this is where the thing comes in, go back and teach your people about this, but don't train them, teach them. Every time I said training in this talk, I'm not supposed to say training in this talk, I'm supposed to say teaching. Every time you go to do training, you're teaching. There's a difference. It'll add the fun stuff back in. So, tell you what I'm going to tell you, tell you what I told you. No process, okay, but there is sort of a process, right? We want to run some training, we want to find the security champions, we want to get them some tools, and we want to get executive buy-in. That's kind of the direction we want to go, right? We need to start by telling people, then find the people who are willing to learn more, and then get them the experience they need to get taught. Then we need to take all that to the boss's boss's boss and get money and approval. Please don't test your stuff without checking with your boss's boss's boss. Just for the record, you can cause all kinds of problems. So those are the 4 things I want you to walk out of here and do. Gotcha? That's all I got for this, except for more stupid memes, of course. Thank you all very much. And if there's any questions or anything, hit me up on Discord. We have the Discord, right? Yeah. They have the little channel for just this thing. Put anything in there you want, and well, not anything, but any questions you have, and I'll be glad to take a look at them then. Because this is a weird thing for questions and answers. So use the Discord and I'll go from there, unless somebody's already entered one and somebody wants to tell me about it. But I don't see anybody, so that'll be good. I'll let you all go have lunch. Thank you very much. Hope you enjoyed it.